Okay, now tomorrow's quiz.
Oh, there's a quiz tomorrow?
It's exactly like the problems from the homework. I even typed in the exact words. I even give you pictures that are labeled. So you don't even have, so
technically,
if you can't do it, it's just laughable.
Wait, is that the quiz?
Tomorrow's quiz.
You made it already?
So out of the first 12 problems, there's gonna be 2 of them. How come only 2? That's because got A part A, B, C like that. That's why. You know how these problems got A, B, C?
Oh, the area dimension, that kind. Oh, that's the last one.
And one of them will involve similar triangles. So that means it's either gonna be the trough problem number 12 or the draining the reservoir number 17. So you already know one of them is either 12 or 17.
So memorize.
Because those are the only 2 that involve similar
So
triangles.
memorize them number for number and then post it.
How about just learn how to do the problem? Because what if they change it a little, like, usually on the AP exam, it's the same thing, but then they just put a little twist there. Okay, here we go. Did I start the video? I hope it did. What if I did? Too bad.
Oh yeah, you did.
Don't move it!
We're on air.
Buddha. Okay, sit back down. And nobody will get hurt.
You're on there, sweat god!
What the? Buddha.
Okay, are you serious? Inga is flying a kite at a height of 300 feet. The wind is cut. Okay, so tomorrow, I will
Inga has
give
a
you a
Buddha.
picture like this if I give you Inga flying a kite. Okay, so this is 300 feet, and here is the kite flying away from her. So isn't this distance changing then? And this is the string. That's changing also. But the kite is flying at a constant height of 300 feet. Things that change, you label with a variable. Things that stay constant, you can put a constant. You guys get it? But tomorrow I'm going to label the picture for you, so it's going to be easy. On the test is another story, though. I'm not going to probably label it out. Okay, how fast must she let out the string when the kite is 500 feet away from her? So what are we trying to find in this problem? How fast must she let out the string?
Why?
We're trying to find dy dt. How fast is y changing? Okay, so 3-step procedure. First step, write an equation, but that's a duh, right? What equation are you going to write here? Pythagorean theorem. Y squared is equal to x squared plus 300 squared. Second step, we take the derivative with respect to time. Zhang. What? So y what? Y prime.
Dot.
No! Were you here yesterday?
Oh.
Y dot.
Y dot equals.
Okay, wait, let's clear this up. When you take the derivative with respect to the independent variable, then you put y prime. But when you do related rates, you're taking the derivative with respect to time, so it's y dot or dy dt. Kind of make up your own now. Okay, continue.
2x squared. I mean 2x plus. Oh, that's it.
That's it?
X dot.
X dot. What's the derivative of box squared? 2 box times the derivative of box plus
0? No, there's nothing.
I heard that, Paulo.
No, but I said there was nothing.
Oh, Paulo. I'll tell you what's nothing. Yes, it's plus 0. Divide both sides by 2. Now we are trying to find y dot. So if you want to compute y dot, you have to plug in numbers for all of these things. Okay, I'm just going to call on you because I can do this. What do I plug in for x dot? Tagawa.
X dot. 25.
Oh, you think you're good? Huh? What do I plug in for y? Lee.
Y. 500.
500.
How long the string is?
And at the moment when this is 500, what do I plug in for x? Teruya.
400.
You have to use a calculator for that? Apparently. it's apparently. That's a 3,
I'll
4.
give her 5.
It's a 3, 4, 5 triangle. I'll tell you right now, Pythagorean triples come up. If you know your Pythagorean triples, then it'll reduce your computations, right?
How many are there?
Infinitely many. So divide both sides by 100, so y dot is equal to, divide by 5, 20, and then you gotta put units. What are the units in this problem? Harada.
Feet per second.
Yep, there you go. See how easy that? Inga flying a kite. Okay, I'll tell you what, that's a little too easy for tomorrow's quiz.
Oh. What?
Just tell her. Just tell her. Be surprised all you want. Sand falls from a conveyor. I remember last year. So sand is falling into a pile that forms a cone. Last year, you know how they're drawing the picture like this. How is sand gonna fall into a pile that looks like that?
Who is that, Mr. Clark?
Plenty people. It's like this. Sand is falling into a pile like that. But tomorrow I'm gonna give you the picture so you don't even have to worry about that. Okay. At the rate of 10 cubic meters per minute onto a top of a pile, the height of the pile is always equal to 3/8 of the base diameter. So the height of the pile, so here, I'll probably give you this picture like that. Okay, so the height of the pile is always equal to, where am I? 3/8 of the diameter, but what is the diameter of a circle? 2 times the radius, so probably we can use that problem. So what is the equation I have to write? The first step is to write an equation.
Area.
No.
Volume.
Volume of the cone. So a volume of the cone is equal to 1/3 pi radius squared height. Oh, okay, we start with that, and then it says, how fast is the height changing? So if I want to find dh dt, that means I just want h's in this equation. So can I get rid of the r?
Yes.
Yeah. So you solve for r in this equation and plug it in here. It's kind of like similar triangles, but it's not. So 2 goes into 8 4 times, therefore r equals 4/3 h. Take that and plug it in there. So that comes out to 1/3 pi times 4/3 h squared times h. And all of this simplifies to?
4 pi. No.
Oh, 16 pi over,
H squared.
no,
4.
no,
9.
27 h cubed. We cannot do algebra 1.
Yes. But you don't need algebra 1, right?
Yes, you do. Yeah, but you gotta write that equation. You still gotta write the equation. So this is the volume. Second step. So the problem is we cannot even write the equation. Second step, take the derivative with respect to time. Come on up. V dot equals. Okay, let's just do it the long way. Throw the constant on the side like an unwanted pet. What's the derivative of h cubed with respect to time?
3 h squared h dot.
There you go. Anyway, for those of you who forget to multiply by the derivative of box, then how, okay, what if you did forget to multiply by the derivative of box? How the heck are you gonna find h dot? There's no h dot in there. You have to multiply by the derivative of box. So, all we have to do now is plug in numbers for v dot and h, but did they give you these numbers?
No.
I think they do.
Oh, they do.
It says right here, sand is falling from the conveyor belt into the pile at a rate of 10 cubic meters per minute. So what is V dot?
10.
10. How fast is the height and the radius changing when the pile is 4 meters high? So what do I plug in for H?
4.
4. Okay, I will leave the computations to you. You guys can solve for H dot, yeah? I hope that's just pre-algebra, please. And then make sure you have the correct units. Okay, now why don't we just, let's just compute it already. 10 equals 16 pi over 27 times 3 times 4 squared. What is 3 times 4 squared? You know what, we should just leave it 3 times 4 squared. You know why? Because 3 goes into 27 9 times. So h dot is equal to 90 over 16 times 16. 16 times 16. 16 times 16.
200.
Wrong, just leave it 16 over times 16. Why?
Because the 16s.
No, because 2 goes into this 8 times and 2 goes into that 45 times. So now you can't do anything, right? So 45 over 128 pi. And what are the units going to be? Imara? Because we're finding h dot. What are the units in this problem? Meters per minute. That is correct. Okay, now, part B. See, this is like tomorrow's quiz. Got part A, part B.
I think this is
But we have class.
okay, never mind. Okay. Sorry.
Oh, never mind. I'll start you.
On.
Sit right here.
Sorry.
Hold up. Which speed quiz is this?
The one we took yesterday. Sorry.
Okay, hopefully I remember to stop you at the correct time. Okay, ready? Begin. Okay, where are we?
B.
Oh, we gotta find, okay, how fast is the radius changing? So we have to find dr dt. Now, what equation can I go to figure out what dr dt is?
R equals 4/3.
Right there, this equation there. So you take this equation, take the derivative with respect to time. So r dot is equal to 4/3 h dot. And do we know what h dot is?
Yeah.
Yeah, right here. This is h dot. So all you have to do is multiply 4/3 times the answer you got here. So even if you got this answer wrong, if you do the right thing here, you're not going to lose any points on the AP exam right there. And then what are the units going to be? How radius over time? How do you measure a radius?
Meters.
Meters per minute, and then okay, I will simplify. 3 goes into 45, 15, 4 goes into 108, 128, 32. So you get 15 over 32 pi meters per minute. There you go. Yeah. What? I'm keeping track of the time. See how easy it is? You write every single problem is the same. You write the equation, you take the derivative, you plug in the numbers. Every problem is the same. You gotta get used to that. Okay, next is number 17. Okay, hopefully we can. Okay, so here's the one. So it's either 12 or 17. These are the two that involve similar triangles. Okay, so we have a conical reservoir. It looks like this. And water, is water going into it or is it being taken out of this thing? What does it say? Is water going in or water coming out? Coming out. Okay, so here's the water, right there. Tomorrow I will give you this picture, or I'll give you a picture. Okay, the radius, 45 meters, that's big for a radius. And the height is 6, like that.
It's a reservoir though.
Wait. Chen, 1 minute remaining. Okay, so what equation am I going to write? The volume of the water. Now look at this water right here. What is it's a cone. What's the formula for volume of a cone? 1/3 pi r squared h. But we have similar triangles. So what can I write? R over h equals 45 over 6. Okay, now you got to figure out what variable are you going to solve for. Oh, you got to actually read the problem. Because part A is asking for how fast is the water level falling. In other words, we want to find dH to T.
H dot R.
So you solve for R. So R is equal to, can we reduce 45 over 6?
Yes.
Yes, divide by 3.
15 over
So 15 over 2H. Take that, plug it in there. So you get 1/3 pi times 15 over 2 h quantity squared times h, and that simplifies to,
Well, we just did this.
yeah. Time's up, Chen, put it on my desk.
Ooh, no, that's not it.
I'll give you a hint, 3 goes into 15 5 times.
25,
What?
5 over 4.
15 is squared, so it's actually like 15 times 15, but 3 goes into one of the 15s 5 times, so it's actually 5 times 15.
75.
75 pi over
4.
Or
4h cubed.
Oh, that's tough.
And then you take the.
That's the toughest part of the problem,
Yeah.
multiplying fractions. Goodbye. Okay, next step, take the derivative with respect to time. So dv dt equals, throw the constant on the side like an unwanted pet, and what's the derivative of h cubed? Is it just 3h squared times h dot?
Solve for h dot.
What?
that's exactly what it is.
Yeah, that's what it is. Please do not forget that h dot, because that's what we're trying to find. So that means I need to plug in a number for v dot and h, but I think these numbers are given in the problem. It says, water is flowing at the rate of 50 cubic meters per minute from a concrete conical reservoir. So what do I plug in for v dot?
Negative 15.
Negative 50. How come not positive 50?
Because it's going up.
Yeah, because the water is coming out, the volume of the water is getting smaller, which means, of course, its derivative got to be negative. And it says, how fast is the water level falling when the water is 5 meters deep? So what do I plug in for h?
5.
5. And then you just solve for h dot. Okay, let's grind out the mathematics here. So h dot is equal to negative 50 times 4 over 75 pi times 3 times 5 squared. Did I do that correctly?
Yes.
Now, on the AP exam, you could just leave it like that, but we are ELN. We are expected to reduce fractions. What can I do? What number can go into both 50 and 75?
25.
25 goes into that 2, and that goes into that 3, and that's it. So negative 8 over, what's 25 times 9? 225, right? 225 pi. And what are the units in this problem? Let's read. Meters per minute. However, read the directions. What does the direction say, Ho Ching? You don't even have your book.
Write your answer in meters per second.
Centimeters per minute, it
Whoa.
says. It says, write your answer in centimeters per minute. So let's do some dimensional analysis.
Oh, times.
So what do we know? If we want to get rid of meters, we need meters on the
One
bottom and
times
centimeters on the
100.
top. We
100.
know 1 meter is equal to
100.
100
But
centimeters.
then they cancel.
What?
25 and 25.
Yeah, 25. Okay, you guys can do that then, right? Okay, I'll do it.
4, 9.
25 goes into this 9
Nine.
times, 25 goes into 4 times, so you get negative 32 over 9 pi centimeters per minute. Okay, that's part A. Part B, how fast is the radius of the water changing? This. So we need to find R dot now. This is just like the last problem. What equation can I go to figure out R dot?
R equals
This one here, the one from the similar triangles. So just take the derivative right there. R dot equals,
15 halves h dot.
that's right. So all you have to do then is multiply 15 halves times the answer you got here, which is negative 32 over 9 pi. And I think we can reduce that, right? 2 goes into 32 16 times. 3 goes into this 5, and that goes into 3. So we got negative 80 over 3 pi centimeters per minute. Because remember, we converted, yeah, to centimeters per minute. So similar triangles. So if you don't do the similar triangles, you cannot do this problem. Just like the trough problem yesterday, you don't do similar triangles, you can't do the problem. Okay, next. That was 17, 20. Where's 20? Oh, come on, 20. This is an insult to my longings, this problem. It should be an insult to yours as well. You're lucky if you get a problem this easy tomorrow. 20. A spherical balloon, so it's in the shape of a sphere, and here's the radius. I'll probably give you this picture. Is inflated with the helium at the rate of 100 pi cubic feet per minute. So what is that? What is that 100 pi cubic feet per minute?
314 cubic.
No. That's V dot, dVdt. Okay, A, how fast is the balloon's radius increasing at the instant the radius is 5? Okay, so what equation do I write?
The volume.
The volume of a sphere. And I told you guys to memorize this one.
4/3 pi r cubed.
Okay, 4/3 pi r cubed. Because I'm not giving you any formulas now. Second step, take the derivative with respect to time. Yung.
V dot is equal to 4 pi 3 r's. No, yeah? Yeah.
Oh, I thought you canceled the 3 when you put it.
Oh, sorry, yeah. R squared r dot.
Yup. That is correct. Hey, did you guys notice something? When you take the derivative of the volume, you get the surface area.
What?
That's kind of a neat thing about spheres and circles. Just like when you have, what's the area of a circle? Pi r squared, right? When you take the derivative, you get 2 pi r dot. That's the circumference. You guys ever notice that? It's kind of a neat thing.
Gonads. Same as loins.
No!
Loins in the lower back. Yeah.
Well, if that's what you want to believe. Anyway, what am I trying to find?
Like awesome.
I forgot the problem right
R dot.
Gonads.
Yeah, we're trying to find R dot. So we need to plug in numbers for V dot and R. What do I plug in for V dot? Well, it says it right there.
Pi.
100 pi.
100 pi.
What do I plug in for R? It tells you right there. 5. So therefore, R dot is equal to 100 pi over 4 pi times 5 squared, which is 25. Are you kidding me? It comes out to 1. And then, what are the units going to be? Radius over time. How is the radius measured? Feet per minute. That's how I like to make my problems though. See how it comes out nice like that. Beautiful. Okay, part B. How fast is the surface area increasing at that exact moment? So, you need to write an equation for the surface area, but like I told you, surface area of a sphere,
4 pi r
4 pi r squared. See now, if you just memorize this one, just take the derivative you got down. You guys ever thought of that? Okay, take the derivative of this with respect to time. Hayakawa.
A dot is equal to 4 pi 2 r dot.
I thought you were going to impress me and multiply the 4 with the 2 and get 8. But I guess not. Okay, and then we're trying to find A dot, so all we have to do is plug in numbers for R and R dot. But aren't these things given?
Yes.
R was 5, R dot was the answer you got in part A.
1.
So tomorrow, same thing, you know with these multiple ABC thing? If you get the answer for part A wrong, but you plug it in correctly here, you're not going to lose any points for part B. That's how they grade the AP exam. And that comes out to 40 pi, and then what are the units? Because we've got area over time. Square feet per minute.
What if we forget to put the square on?
What?
What if we forget
That's automatic minus 1, because the units are just 1 point. Every free response is worth, there's 6 free response questions on the AP exam. 9 points each, but it's going to be like ABC or ABCD. So you can see that just getting the units wrong, that's like 11% of the problem gone. Just because you put the wrong units. Come on, we're Iolani. How can we not put correct units?
So if we get the answer
1
wrong,
team.
then put the correct unit.
Then that's why the correct answer is only worth 1 point, but it's the work. Did you write the equation? Did you take the derivative correctly?
Like tomorrow on the quiz.
Oh, I graded pretty much the same. However, if you just don't do any work at all, and then you just put square feet per minute, you don't get anything. No, because when I used to grade AP exams, that's what they told us. This is worth 1 point unless they don't do anything else.
So if they just wrote like a bunch of whatever and then
Yeah.
it's
Then,
okay?
no,
No.
no, but it's got to be like math in that problem. You cannot just write, oh, 2 plus 3 is 5 square feet per minute. No, you're not gonna get that, no. Okay, number 21. Come on, you guys gotta at least ask like the ones that are interesting. These are like, come on, that's so mundane. Oh, here, 21. Okay, hauling in a dinghy. I like this. You guys know what a dinghy is, right? Yeah, it's a small boat. That's what it is.
A what?
I'm afraid to ask. The dinghy is pulled toward the dock by a rope from the bow through a ring on the dock 6 feet above the bow. So this doesn't change. See, look, they gave you the picture. That's 6 feet. It doesn't change.
I don't understand the picture. Where's the boat?
The boat is right here. Look, they have the boat in the picture. The boat is right. You don't. Okay, you don't come. Okay, you don't have your boat. You don't come to class. You just report to the other class, other calculus class.
Yo.
Yeah, she's probably not teaching calculus there, but you report there.
Oh.
How fast is the? Okay, so here's the rope attached to the boat here, and then you're pulling in the rope. See, the rope is going through the ring. The rope is here, and then you're pulling it down.
Pulley. Gotcha.
Like
So is this distance changing or it's staying the same?
changing.
It's changing, whatever letter you want to call it. What about this one?
Changing.
Changing. Okay, now I'll probably give you this picture tomorrow with all the letters and numbers in already. So all you have to do is write the equation, which is a Pythagorean theorem. X squared plus 6 squared is equal to y squared. Second step, take the derivative with respect to time. Evans.
Derivative with respect to time.
Enough of your stalling tactics.
2x times x dot equals 2y times y dot.
There you go, and the 2's cancel out, right? And what are we trying to find in this problem? How fast is the boat approaching the dock? So are we trying to find y dot or x dot?
X dot.
We're trying to find x dot. So if I want to find x dot, I have to plug in numbers for these 3 other things. But if you read the problem, you can figure it out. The rope is hauled in at the rate of 2 feet per second. So what is y dot?
2.
No, -2.
Oh.
Because if you haul in the rope, the boat is getting closer to the dock. That means x is getting smaller. Y is also getting smaller too, right?
Yes.
Yeah, it's -2. That's at least 1 point tomorrow now, that negative sign. At the moment when 10 feet of rope are out. So, no, that's y. This is the rope. This is the rope here. Y is 10, and then of course, again, this is a 3, 4, 5 triangle. So this is 8. So at the moment in question, x is 8. Come on, this is an insult. X dot is equal to -20 over 8, which can be reduced to negative divided by
5 over
4, 5 over 2, and what are the units?
Feet per second.
Feet per second.
Not a lot of feet.
These are just fake real problems. These aren't real problems. Okay, there's a part B to this. At what rate is this angle changing up here?
Oh.
Okay, let me erase these numbers here so you don't get confused. So what? Now there's 12 equations you can write. It doesn't matter which one you pick.
Sine.
You want to go tan theta equal x over 6, or do you want to go cosine theta equals 6 over y, or do you want to go sine theta equals x over y, or do you want to go secant theta is equal to y over 6?
Cosine.
Somebody pick a good one.
Cosine. Tangent.
Tangent is good. Why is tangent the best? Again, I told you guys why. Tangent theta is equal to opposite over adjacent. Why is that better than, somebody said cosine, yeah? Cosine, was that just a guess? Cosine theta equal adjacent over hypotenuse. Because over here, the variables in the bottom, it's harder to take the derivative of that. I mean, it doesn't matter. It's just a little more effort. But this one is like, you just throw the 1/6 on the side, like an unwanted pet, right?
Yes.
Okay, and then, since we're trying to find theta dot, I would highly suggest, and you don't have to do this, but I would highly suggest you solve for theta, and you get that. Theta equal tan inverse x over 6. That way when you take the derivative, you get theta dot right off the bat. You know what I'm talking about? Whereas if you take the derivative of this, like in this form, it's going to be secant squared theta, theta dot. You know what I'm talking about?
Wait, so we gotta know our derivatives of.
Oh, you gotta know all your derivatives that's on that page. So theta dot is equal to, what's the derivative of tan inverse box? 1 over 1 plus box squared times the derivative of box. But if you just think of this as 1/6x, the derivative is 1/6x dot. So in order to figure out theta dot, you gotta know x. Do we know what x is?
8.
Yeah, it's 8, so plug in 8 here. Oh, let's just do it over here in the next step. 1 plus 8 over 6 squared times 1/6 times x dot, but we figured out x dot in the previous problem. -5/2. And then what are the units going to be? We're measuring an angle. Angles are always measured in, so radians per second. And I will leave the simplification to you. Come on. You can't expect me to do arithmetic as well. Are we getting the hang of it yet? Because not tonight you get the hard problems. You gotta, I'll give you a hint. One of tonight's homework problems, you gotta use the law of cosines. What? I'm not gonna do it. You can't make these. 24. Wait, I didn't assign 22?
No, 20 is not there.
Oh yeah, I did, because I'm looking at that problem and going, I have to, because this one might be on the quiz. Okay, do you guys understand what's happening in this problem? Okay, this might be the last one we have time for. Look, they give you a picture. Okay, there's a balloon that's rising like this, and there's a bicyclist going that direction. Okay, you got a balloon going up and a bicyclist going this direction. Is this distance changing or staying the same?
Changing.
What about that one?
Changing.
What about that one?
Changing.
Okay, they're all changing, so you gotta label variables. What did they do in the picture? X, Y, Z? No, they go X, Y, S. Whatever. If I were me, if I were giving you a picture, I would go X, Y, Z. Okay, first step, write an equation, that's a dub.
Pythagorean theorem.
Okay, x squared plus y squared equals s squared. Take the derivative with respect to time. Taruya. Okay.
2s s dot. Oh, sorry.
Oh no, that's okay, we'll do it on this side then.
Sorry.
No, no, I'm sorry. So continue. So 2s s dot equals.
2s s dot plus 2y times y.
Okay, there you go. And can I divide everything by 2?
Yes.
Yeah.
Although I have no doubt you guys wouldn't do that. I'd make the numbers bigger tomorrow, yeah?
Absolutely not.
Now, what are we trying to find in this problem? How fast is the distance between the bike and the balloon changing?
S dot.
We're trying to find s dot, which means we need to plug in numbers for all of these other stuffs. Okay, so here we go. Now this is tricky now. The problems are getting tougher. It's getting tricky now. The balloon is rising at a rate of 1 foot per second. So what do I plug in the 1 for?
The Y.
Y dot.
Y dot. Dunga. The bicyclist is traveling at 17 feet per second.
Negative 17.
No, 17.
Why is it
This distance is getting bigger.
Why is it? Oh, because it's going towards the. Never mind.
Boomba.
If it's getting bigger, the derivative comes positive. Okay, now here's the hard part. What do I plug in for y? Saito. What do I plug in for y?
65.
Hmm?
Isn't that 65?
No. You gotta read. Because they're asking
1.
3 seconds later. So the balloon is at a height of 65 feet, right? And it's moving up at a rate of 1 foot per second, or is it meter? 1 foot per second. So 3 seconds later, what is the height of the balloon? You're correct, 68. Everybody got that? 68. 65 plus 3, that's why. That's why you gotta read. Okay, the bicyclist is going 17 feet per second, so 3 seconds later, what do I plug in for x? Paulo? Yes, so just read me what you got on your paper. Look, you still look down even though you got nothing there. That's a good one. Okay, look. Okay, if you read the problem, the bicyclist is right beneath the balloon. He's traveling at 17 feet per second. So what is this distance 3 seconds later? Rate times time equals distance. Okay, there you go, 51. Then, therefore, what do I plug in for S? Zang? This is I'll give you a hint, it's a Pythagorean triple. 51, 68. How can the hypotenuse be smaller than the other two sides? At least get something bigger than 68. Or I'll give you a hint. Maybe divide by 16. I mean 17. 17. Okay, I'll give you a hint. This is equal to 17 times 4. This is equal to 17 times 3. So this one's going to be 17 times 5. It's the 3, 4, 5 triangle, which is 85. There you go. So S dot is equal to these numbers. Here, why don't we just finish it up? 51 times 17 plus 68 all over 85. Now, you're not going to have a calculator. I expect you to simplify this. We got 1 minute. Come on. Factor out 17 at the top. And then what's going to be left? Are you kidding me? 51 plus 4 all over 85. But 17 goes into 85
Right.
5 times. So you got 55 over 5, which is 11. Look how beautiful that is. That's a beautiful problem. And what are the units? How do you measure S? How is S measured? Feet per second. Okay, that's all we have time for today. Okay, number 24. Got that same cone problem. Coffee is draining out of it. It's just a variation of the other one. Similar triangles. Let's see if we can do that on our own. Woo! And then we got the hard ones. Oh man, number 30 is a doozy. You guys are gonna, your brains are gonna explode on number 30. Oh!
Hey, why